So for question 6a, we've been asked to find the integral of tan squared x with respect to dx. Okay, so here we have a trig type integral. So it will most likely be the case that we'll have to use one of our standard trig identities to reduce this down to something that can be integrated via standard trig integrals. Okay, so you should be familiar with this identity. Q layer 1, sine squared x plus cos squared x is identical to 1. Okay, so if we call this identity 1 from 1, if we divide everything in this identity by cos squared x, what we can do is we can derive another trig identity which we can use to reduce this down to one of our standard integrals. Okay, so sine squared x divided by cos squared x is in fact tan squared x. Cos squared x divided by cos squared x is 1, and 1 divided by cos squared x is sec squared x. Okay, so we've derived one of our other standard trig identities. Okay, so we can simply just substitute this in. So we can say the integral of tan squared x with respect to dx is going to be identical to the integral of sec squared x minus 1 with respect to dx. Yeah, if I'm just minusing 1 on both sides of this identity and then substituting tan squared x into there. And we know now that sec squared x is a standard integral. Okay, you should know that. If you don't, I recommend you remember it. Okay, so sec squared x integrates to tan x, and minus 1 will differentiate to minus x. And we can't forget our constant of integration, c. Okay, so if you didn't know, if you haven't memorized the fact that tan x is the integral of sec squared x, what you can do on the side of the page is quickly differentiate, find the derivative of tan x. Okay, and you know this will be the same as, this will be in fact identical to finding the derivative of sine x over cos x. Yeah, and then here you can use the quotient rule, and that should give you the result sec squared x. Okay, so if you know the derivative of tan x is sec squared x, then the integral is just going the opposite way. Yeah, the integral is going backwards because integration is the reverse of differentiation. Okay, but for now that's our final answer right here. Okay, thank you very much, and I hope this video helped.